Welcome to Tomorrow Unveiled, where we peer into the future as it unfolds around us. Now, when you hear Rise of the Machines, what pops into your head? Probably that classic sci-fi dystopia, right? Robots marching in lockstep.
Yeah, something like the Terminator, maybe?
Exactly. We'll hold that thought. Because the final week of June 2025,
Yeah.
it delivered a kind of Rise of the Machines. But it was, well, surprising, exhilarating, and definitely not dystopian. It felt like a critical inflection point for humanoid robotics, a moment when these, advanced machines truly began their transition from labs, from experiments, into something much more tangible. Real-world deployment.
And the acceleration we've seen, just in those 7 days, it's truly remarkable. So in this deep dive on Tomorrow Unveiled, we're going to take you on a journey through the most significant breakthroughs. Our dedicated research team has compiled all this, and our mission, really, is to uncover the most important nuggets of knowledge.
Find the surprising facts.
Exactly. About this rapid evolution. Help you understand why this particular week felt so pivotal.
Absolutely. We're going to dive into the untethering of AI, which means smarter, more autonomous robots that don't always need that cloud connection. We'll explore some fascinating new robot hardware, and they have very different design philosophies, which is interesting.
Yeah, very different.
And, of course, we'll look at some incredible real-world demonstrations showing what these bots can actually do. Plus, the broader implications, society, the economy, all that. So let's get started.
Okay. So when we talk about this rapid evolution, we really have to begin with the brains of these bots. Because robotic intelligence, it's undergoing a paradigm shift.
A big one.
A really big one. And one of the biggest announcements came from Google DeepMind, their Gemini robotics on-device model.
Our research team really flagged this as a game changer. Gemini robotics on device. It's a vision language action model, a VLA.
That's right, VLA. And it's engineered to run entirely locally, right there on the robot's own hardware.
Okay, so is that untethering aspect, is that really the most significant part? What problems does cutting that core, that constant cloud connection, actually solve for, real-world use?
Oh, it's absolutely foundational. Think about the critical barriers we've had. Latency, for one.
Right, the lag time.
Exactly.
Yeah.
For robots doing something delicate, maybe complex assembly, or just navigating a chaotic factory floor, even a tiny delay sending data up to the cloud and back, well, it could be problematic, maybe even dangerous. Local processing means near instant reactions, and that unlocks entirely new levels of precision and safety.
Okay, makes sense.
And then there's connectivity. Robots can now operate completely offline. Think remote areas, disaster zones, or even just inside buildings where Wi-Fi or cell signals are, spotty.
Or just not allowed, like in a secure facility.
Precisely. So this radically expands where and how these machines can actually be deployed.
And it's not just fast, it's also adaptable. Our team noted it's the first VLA model from DeepMind that developers can actually fine-tune themselves.
That's a key point. Yes.
Which means you can teach it new skills with, surprisingly little new data. Something like 50 to 100 human demonstrations.
That's the claim. As few as 50 in some cases. It makes training much faster and cheaper. We're seeing demos of it doing highly dexterous things.
Yeah.
Unzipping bags, folding clothes, assembling products, tasks that require, real finesse.
And crucially, our research mentioned it can generalize across different robot hardware, like they showed it working on Apptronic's Apollo Humanoid too.
Yes, that ability to generalize is huge. It suggests we're moving towards AI that isn't just tied to one specific robot body.
That feels like a big step towards some kind of universal robot brain, doesn't it?
It kind of does. And hot on its heels, Nvidia also made a really significant move. Their Isaac GR00T N1.5 ecosystem.
Yes, Chores.
Another open foundation model, also designed to give humanoids reasoning skills, but with a particular emphasis maybe on natural language understanding for complex tasks.
Nvidia's strategy here seems very ecosystem-focused. Our research team highlighted their Isaac GR0T Dreams blueprint, which lets developers generate huge amounts of virtual practice data, right?
Right. Synthetic data generation.
Of just a few human demos. So the robot practices 1,000,000 times in simulation.
Before it ever tries it in the real world. This massively accelerates training. It's all about that simulation to real pipeline.
And hardware partners are already jumping on board, like Neura Robotics. They're using GR0T for their new humanoid.
Yes, Neura is leveraging GR00T for their 4NE1 bot, which really speaks to its immediate relevance. People are building on it now.
What's truly striking, our research suggests, is that having these two major players, Google and Nvidia, announce these platforms almost simultaneously. It signals a new competitive front, doesn't it?
Oh, absolutely. It's the battle to create the dominant software platform, the operating system, if you will, for general-purpose robots.
Like iOS versus Android, but for robots.
Exactly that kind of platform war. It's not just about the code itself. It's about controlling the future ecosystem. The platform that wins will dictate how developers innovate, what kinds of skills robots can learn easily, who makes money. It's a really strategic battleground.
And a huge part of that platform has to be safety, right?
Yeah.
Our research brought up things like the Loverb framework from UC Berkeley, enhancing AI for whole body control driven by vision and language.
Yeah. Coordinating complex movements safely is non-trivial.
And then there's that Neura artificial skin technology on the skin. Our team flagged that as a key safety feature. It detects touch before contact.
Yes, it senses proximity, which is absolutely crucial if you want robots working shoulder to shoulder with humans outside of the traditional safety cages you see in factories today.
Right. Allows for real collaboration.
Which leads us perfectly from the brains to the bodies of these bots. Because this past week also saw the unveiling of some truly incredible new humanoid platforms, and like we hinted, each designed with very different philosophies.
Okay, let's talk about the Neura Robotics 4NE1 first, their third-generation model. Our research describes it as the cognitive collaborator. Sounds impressive.
It is. Specs-wise, it's about 1.8 meters tall, weighs 80 kilos, and the payload capacity up to 100 kilograms.
Wow, 100 kilograms. That's definitely at the upper end for humanoids, isn't it?
It really is. And Neura's design philosophy, it's all centered on that safe, intuitive human-robot interaction. It has 360-degree perception, and that omniskin, that artificial skin we mentioned.
And their ambition seems huge. Our team noted they're targeting 5 million units by 2030.
Yeah, very ambitious scaling plans. They're positioning the 4NE1 for complex industrial tasks initially, but also see future roles in service industries, maybe even domestic environments eventually. They're clearly betting big on that general-purpose future powered by Nvidia's GR00T.
Okay, so that's the generalist. Then, in stark contrast, we have the Hexagon Aeon. Our research team calls this one the industrial pragmatist.
A very different beast. Not a general-purpose robot trying to do everything. It's specialized, laser-focused on industrial applications, manufacturing, aerospace, logistics.
And its unique value comes from Hexagon's background, right?
Yeah.
Deep integration of their precision measurement sensors.
Exactly. So it can do things like component inspection, quality control, even creating digital twins of equipment or processes right there on the factory floor. It's leveraging Hexagon's core strengths.
And what's particularly interesting, our research highlighted, is its design choice.
Yeah.
Wheels, not legs.
In its initial version, yes, wheels instead of bipedal legs. It's a pragmatic choice. It prioritizes stability, energy efficiency, and crucially, immediate reliability on flat factory floors. Less complexity, fewer failure points right now.
Makes sense for getting started quickly.
It also features a self-swapping battery mechanism for continuous 24/7 operation. And it's not just a concept. It's already being piloted with industrial giants like Pilatus Aircraft and Schaeffler. So real-world validation is happening.
So our research team really emphasized this point. These two robots, the Nvidia 4NE1 and the Hexagon Aeon, unveiled in the same week.
Yeah.
They kind of embody these fundamentally different philosophies.
They really do.
You've got the 4NE1 representing that general-purpose vision. High risk, maybe, but potentially high reward for doing almost anything eventually.
The do-everything bot.
Right. And then the Aeon takes that specialist pragmatic approach, focused on solving specific industrial problems right now for presumably quicker commercial viability. Do you think these two approaches will just coexist, or will one eventually win out, especially as, the leg technology gets better?
That's a fantastic question, and I think it really points to a maturing market. We're seeing segmentation. For the foreseeable future, I absolutely think we'll see both approaches thrive.
Really?
Yeah. The general-purpose humanoid, it promises immense long-term versatility. That's the dream. But the specialist, wheeled robot like Aeon, it offers immediate, reliable solutions for specific, high-value industrial problems today. They're solving different sets of challenges, really.
Okay, so room for both. And it's not just about these big industrial players either, is it? Our team also highlighted efforts to sort of democratize robotics. The Berkeley Humanoid Light,
Ah, yes, the open source project.
an affordable, open-source, 3D printed robot. Designed for researchers, educators, even hobbyists. Apparently, the hardware cost is under $5,000. That's incredible for a humanoid platform.
It really is. It lowers the barrier to entry significantly. It's all about fostering innovation at every level, getting more people involved in actually building and programming these things.
Spreading the knowledge.
Exactly. And then, you get these niche, sometimes almost wild, but groundbreaking hardware projects that truly push the boundaries. Our research team brought up the Iron Cub 3,
The jet-powered one.
the jet power humanoid. From the Italian Institute of Technology, it actually demonstrated controlled flight using jet thrusters on its feet and hands.
That sounds like something out of Marvel.
It kind of does. Now, obviously, it's highly specialized. You won't see these delivering packages soon. But it dramatically shows the sheer range of capabilities we might eventually see in human-like robots. It pushes our imagination about what's possible.
Speaking of capabilities
Yeah.
and maybe limitations, our research team highlighted a really critical bottleneck. Something China seems to be strategically tackling. Humanoid battery technology.
Ah, yes. Power. Always a challenge.
Battery tech is apparently a massive limiting factor, especially for dynamic high-power movements. The research mentioned a backflip, for example.
Right. Something really dynamic.
It needs an instantaneous power discharge rate from the battery that can be over 100 times greater than what our normal consumer electronics like phones or laptops require. That's staggering.
It is. And it creates this huge engineering trade-off. You want high energy density so the battery lasts a long time, but that often means more weight.
Which makes dynamic movement harder.
Exactly. And then you need high discharge rates for those power bursts, but that can impact the battery's overall capacity or even its safety if not managed properly.
So what's China's response? Our research flagged a concerted effort.
Yeah, a really focused push to develop domestic robot-specific batteries. You have companies like CATL, already a global giant in EV batteries, now investing specifically in humanoid tech through a company called Galbit.
Okay.
And another major player, BTR New Material Group, is launching new battery lines. The FLX series, which is semi-solid state, and the Guard series, which is all solid state.
So moving beyond traditional lithium-ion.
Towards next generation tech, yes. Semi-solid and all solid state batteries promise better energy density, potentially better safety, and maybe higher discharge rates too.
So this isn't just like a technical upgrade. Our team's analysis suggests this is a clear industrial and geopolitical strategy for China. Build a robust domestic supply chain, gain a competitive advantage in what's going to be a absolutely crucial enabling technology for the whole robotics future.
It definitely looks like a strategic long-term play. They see where this is going.
Okay. We've talked about the brains, the AI, we've talked about the bodies, the hardware. But what about seeing these robots in action? This past week apparently featured some amazing demonstrations, some real-world proving grounds.
Yes, putting the tech to the test.
Like the Robo League tournament in Beijing. Our research called it a groundbreaking 3v3 autonomous robot football match, like a precursor to the World Humanoid Robot Games.
Exactly. And it was a fascinating test of both the cerebrum, the decision-making AI, and the cerebellum, the physical control.
I see.
Because all the teams use standardized hardware, the Booster Robotics T1 Humanoid. So it wasn't about who had the fancier robot body. It was purely a test of the AI algorithms, who could program the smartest strategies, the most stable walking, the best recovery from falls.
Ah, so a level playing field for the hardware.
Right. The robots operated with full autonomy, using their visual sensors for real-time strategy, figuring out where the ball was, where teammates and opponents were, and, importantly, how to get back up if they fell over. It was a true stress test for integrated AI in a dynamic environment.
And how did they do? Our research noted, significant achievements in coordination, some strategic play, but also that some robots still stumbled, needed staff help sometimes.
That's right. It really highlighted those persistent challenges in robust dynamic balancing and recovery. Even the most advanced robots, well, they can still have an off day on the field.
I guess it's a great example of that gap between an impressive, controlled demo and consistent, reliable performance in the messy real world.
Absolutely. And speaking of real-world environments, maybe even messier than a football pitch, 1X Neo. That's a robot backed by OpenAI. They showcased its ability to learn and perform common household chores, like doing laundry.
Laundry bots. The significance of that feels huge, though. Mastering tasks in our homes. They're unstructured, unpredictable environments, right?
Totally unstructured.
You've got soft things, deformable objects like clothes, different washing machine interfaces. It requires incredibly sophisticated perception, really fine motor skills, and some genuine reasoning. Our research actually described this as the holy grail for generalist humanoid skills.
It's a massive challenge.
Frankly, if a robot can reliably fold my fitted sheets, that would be the real breakthrough.
We're probably still a ways off from a perfect fitted sheet folding. But laundry, clearing tables, simple tidying, these are major steps for operating in human spaces.
And what's particularly exciting, maybe even a bit meta, is how AI is now influencing the actual creation of robot hardware. Our research team highlighted an MIT CSAIL example.
Oh, the jumping robot, yes.
Where generative AI was used to redesign the robot's leg linkages, and the AI-generated design resulted in a leap that was 41% higher than the original human-conceived design.
Exactly. It's not just AI controlling the robots anymore. It's AI designing better robots than humans can, at least for specific tasks. That's a really powerful feedback loop starting to happen.
We're also still seeing development in human-in-the-loop systems, right?
Yeah.
It's not all full autonomy yet. PL Robotics showed off their Tiago Pro at Automatica 2025.
Yes, demonstrating effective teleoperation and shared control. It really highlights that full autonomy isn't always the immediate goal or even the most practical one for many complex tasks right now. Human guidance, human oversight, it remains crucial, especially as we bridge that reliability gap we talked about.
Okay. And are we seeing these actually get deployed beyond pilots? Our research team reported on what they called a major milestone, Foxconn and Nvidia.
Yes, that's a big one. Their plan is to deploy humanoid robots at Foxconn's new plant in Houston, Texas, starting by Q1 2026.
Wow, that's soon. What will they be doing?
Assisting with AI server assembly, which is quite precise work, and also material handling, moving things around the factory. This is a huge validation for humanoid adoption in high-volume precision manufacturing. Foxconn is, a giant.
Definitely a significant move. And the applications seem to be broadening really rapidly. Our team also found that the Indonesian National Police, Polri, in their long-term strategic plan up to 2045, they're explicitly considering humanoids.
For public safety roles.
Yeah, things like facial recognition, maybe traffic monitoring in the future. It's clear these machines are starting to be envisioned outside the factory walls, moving into our daily lives, our public spaces.
It certainly feels like things are moving fast, which brings us to the bigger picture, maybe.
Okay, let's unpack this a bit. If you're finding this insightful, and we hope you are, please take just a moment to like this video. If you're on YouTube, subscribe to Tomorrow Unveiled, and definitely hit that notification bell so you never miss an update on the future as we see it unfolding.
And what's fascinating here is, well, if you're listening on a podcast service, maybe Apple Podcasts or Spotify, we would be incredibly grateful if you could leave us a rating and review for Tomorrow Unveiled. It sounds like a small thing, but it genuinely helps us reach new listeners who are curious about these topics.
It really does. Okay, so the bigger picture, the economic impact. Our research team found some, frankly, mind-boggling forecasts.
The numbers are pretty extraordinary, yeah. Projections ranging from $38 billion market by 2035, that was Goldman Sachs, all the way up to a potential $5 trillion market by 2050 from Morgan Stanley.
$5 trillion. What's driving those kinds of numbers?
Several powerful forces converging, addressing chronic labor shortages, which are becoming acute in many developed economies, the pressures from aging populations, fewer working-age people supporting more retirees, and these big national initiatives you see in the U.S., Europe, China, Japan, to reshore manufacturing, bring production back home. Humanoid robots are seen as a key enabling technology for all of that.
And the cost factor is huge, too. Our research projected the unit cost dropping dramatically, from maybe $150,000 or so today,
which is still very expensive,
down to potentially as low as $15,000 or $20,000 in the long term, and operational costs maybe like $12 per hour for a robot working 24/7.
Yeah, when you factor in the potential for round-the-clock work with minimal downtime compared to human labor costs, benefits, breaks, the economic incentive becomes incredibly powerful. It's hard to ignore those numbers if you run a large operation.
But there's always a but, isn't there?
There's always a but. Despite all the hype, the incredible progress we've just discussed, our research also highlighted what they called a significant gauntlet of deployment. Real hurdles that still need to be overcome for widespread adoption.
Okay, like what?
Well, first, the total implementation cost. It's not just buying the robot. You need substantial investment in system integration, making it work with your existing systems,
Hmm.
software customization, workforce training, teaching your staff how to work with these robots, and potentially significant infrastructure upgrades to your facility.
Right? It's a whole ecosystem you're buying to, not just a machine.
Yeah.
And you mentioned earlier the complexity, especially for the two-legged ones, the bipedal humanoids.
Exactly. The mechanical and software complexity is immense, maintaining robust 247 reliability in a demanding industrial setting. It's a huge challenge. A factory needs predictability, it needs uptime.
And those complex dynamic balancing systems, needing constant micro-adjustments, they just have more potential points of failure than, say, a simpler wheeled robot or a stationary arm.
Precisely. And our research specifically calls out things like thermal management. These things generate a lot of heat working hard, and that continuous balance control as critical barriers that still need consistent breakthroughs for nonstop operation.
Okay, what else is in this gauntlet?
Safety concerns, especially as we imagine these robots moving outside controlled factory floors, operating heavy, powerful machines in close proximity to untrained humans in unpredictable environments like retail stores, hospitals, or even our homes.
Yeah, that raises huge safety questions.
Absolutely. It's going to require rigorous testing, comprehensive certification standards, which mostly don't exist yet for these kinds of robots, and really robust regulatory oversight before these machines can truly integrate seamlessly and safely into our daily lives.
And finally, our research mentioned there's still that AI generalization gap.
Yes. The difference between an impressive demo where a robot does a task maybe 5 times perfectly under specific conditions and a system that performs that same task with, say, 99.9999% reliability day in and day out across countless variations in lighting, object position, unexpected obstacles, that gap is still vast.
Okay.
And this kind of explains why those more pragmatic, specialized solutions like Hexagon's wheeled Aeon might see commercial success faster. They're tackling a narrower problem domain where achieving that high reliability is, relatively speaking, easier than for a generalist humanoid trying to do everything everywhere.
So what's a realistic timeline look like then, according to research?
Well, the consensus seems to be gradual adoption. We'll see initial pilot programs, more of them, in controlled industrial settings, likely between now and 2027, then tackling tasks with increased complexity from maybe 2028 to 2033.
But widespread adoption. Thousands of units.
Unlikely before the end of this decade, maybe even later, for really complex general-purpose roles. Those validation cycles, proving out the reliability and safety, they just take time.
So wrapping this up, what does this all mean for you, our listener? That final week of June 2025, it really felt like a pivotal moment. Our research confirms it. We saw these advanced physical platforms, we saw AI untethering becoming more adaptable, and we saw clear market demand all visibly converging.
Yeah, that convergence is the key takeaway.
The rise of the machines, it's truly transitioning from, a sci-fi concept into a tangible, accelerating industrial and economic reality. And it's being driven by these really powerful market forces we discussed.
And the strategic race is on. It's not just between companies like Google, Nvidia, Neura, Hexagon. It's between nations pushing for leadership in this field. And it's between these fundamentally different technological philosophies, the generalist dream versus the specialist reality. It's a future being built, quite literally, right before our eyes.
So here's a final thought to ponder. As these humanoids become more capable, better at navigating our world, performing tasks we thought only humans could do, what unexpected new roles might emerge for us, the humans, working alongside, collaborating with, maybe even managing these machines?
That's a deep question for the future.
It is. We'd love to hear your thoughts on all this. Whether you're watching on YouTube or listening on your favorite podcast app, please leave a comment and let us know what you think about this rise of the machines.
And if you found this deep dive insightful, please do take a moment to like the video on YouTube, subscribe to Tomorrow Unveiled, and make sure you turn on notifications. That way, you won't miss our next exploration of the future.
And finally, if you're listening on a podcast service like Apple Podcasts or Spotify, we would be so grateful if you could leave Tomorrow Unveiled a rating and perhaps a short review. It truly does help us reach new listeners. Thank you so much for joining us today. We'll see you next time on Tomorrow Unveiled.